Hello, Algebra 9 students. Before we move on to the next part, I'd like to take some time and go back and review some of those problems that were given to you there that were due today from section 4. Now, first of all, I feel like I need to apologize here for what may happen. We're using Delta Math to do the assignments, and sometimes it just doesn't match up exactly with what we go through in class and what's in the book. Um, so what I'd like to do is clarify for you when you see something like number 2 and it's telling you to find the value. That's something that we are going to talk about different techniques of solving equations later. That's really not what should be included here in chapter 1. The problems that we looked at in class were all using substitution and testing whether or not a particular value was a solution. Okay, so again, the directions here don't match up exactly to what we talked about in class with the quiz that I'd like to give you maybe before we actually take the test, and the questions on the test itself that'll come later are going to be like the notes that I sent you in OneNote rather than these types of problems. So if these were a bit confusing, please don't worry about it. Hopefully you tried your best to see what was going on. Again, what you will see is more along the lines of something like that, where they're not only going to give you the equation, but they will suggest a number. And for you, it's a matter of doing the substitution and writing it out. So if we're saying determine if 5 is a solution to the equation, we'd substitute 5 plus 17 and see if that is equal to 18. Well, hopefully fairly obviously, 5 plus 17, that I think is 22, and 22 is definitely not equal to 18. So our answer here is no, it is not a solution. You also we looked at equations that were in the form of doing some multiplication. Did. So they're giving you the suggestion of 2, so we're going to write this out and take the black pen. Don't write in red, please. This says 2 times x is equal to 4, so we're going to take out the x and we're going to put 2. We're going to substitute that in its place. Hey, look, 4 equals 4. Yes, it is a solution. And again, quiz and test for this first chapter here, that's all you're going to need to do. Now, there were, I think, some of the examples that we went through. where they had us test different things rather than just one value. It's a lot of typing to just one problem here. All right, so we're going to, in sequence here, substitute 10, 20, and 30 and see what happens. So if we substitute 10, negative 4 is equal to 10 divided by negative 5. Well, 10 divided by negative 5 is negative 2. Negative 2 is not equal to negative 4. So no, 10 is not a solution. Do it again. Negative 4 is equal to 20 divided by negative 5. Well, 20 divided by negative 5 is negative 4. Hey, look, that one works. We got another one to check. Maybe there's more than one solution. That's entirely possible with algebraic equations. Substitute 30 divided by negative 5. But wait a minute, 30 divided by negative 5 is negative 6, not negative 4. So in this case, the only suggested value that is a solution is 20. Then once we get to the inequalities, now this was a lot closer to what we did in class there. Select the values that make the inequality 9 times u is greater than negative 90 true. Okay, we'll deal with the directions beyond that in a moment. So again, it's substitution. If we take 9 times negative 20, that's negative 180. Is negative 180 greater than negative 90? If you think about the number line and you put those two values on the number line, greater than, again, our symbol here points to the right. Is negative 180 to the right of negative 90? Is it greater than? No, it's not. We substitute in 15 next. So we'll take 9 times negative 15. Well, that'll be negative 135. Is negative 135 greater than 90? No, it is not. Keep going. 9 times negative 13 will give us negative 117. Well, I guess we could say we're getting closer to negative 90, but there's no symbol that I know of that says closer. Is it greater than negative 90? No. 9 times negative 11. That'll give us negative 99. Still not greater than 90. 9 times negative 10. That'll be negative 90. Is negative 90 greater than negative 90? No, it's equal to. It's not greater than. Again, our symbol here simply says greater than. It does not say greater than or equal to. We have to reject this one. 9 times negative 9 will give me negative 81. Is negative 81 greater than 90? Yes. Yes, it is. It's to the right of, again, that's way down there, off to the left on the number line. But negative 81 is to the right of negative 90. That is part of the solution set. There's a whole group of numbers that will make an inequality true. So 9 times negative 7 will give me negative 63. Is negative 63 greater than 90? Yes. Is negative 45 greater than negative 90? Yes. Is 0 greater than 90? Yes. Now, back to the directions there, where it said write an equivalent statement, changing that inequality in terms of the value of u. Here, let me even do this. Don't worry about that. We will save that for another day. And again, on Delta Math, if you didn't get that part of it right, please don't worry about it. I'm not going to deduct any points. If you can get that first part right, that's my big concern here. Okay, I hope that helps your understanding, and I hope maybe that eliminates or reduces at least some of your anxiety. Your quizzes and tests are going to match up with what is in OneNote, not necessarily what's on Delta Math. With Delta Math, I'm going to try and get as close as I can to the things we've talked about. And again, there was some practice there. Hopefully, going forward, it's going to be easier to get the Delta Math to match up almost exactly with the assignments I'm going to give you. So again, if you have any other questions about that, please make a note of it somewhere, and next time we're together, we will talk about it.